We are alive. We are alive. What's up? How is everyone doing today? Hopefully the audio is nice and good. I'll put on a little music here in a second here. I'll let some folks get in here first. While I mess around with some music stuff. Trying to find some music for us to listen to. Gotta be careful here. Gotta be careful.
Run free and dive into the sky. Hear the wind crying out its prayer. Why are we so ashamed to be alive?
But pretty much the goal of today's stream, or tonight's stream rather, is to, to learn some Rust. And so the reason it took me so long to hop on is because I was going to be in NixOS tonight. However, when I set up the stream and I set up OBS and all of that stuff, I went to import my string key from YouTube. OBS from NixOS did not want to connect to YouTube. Now, I'm pretty sure that's only because of a certain setting or because I haven't configured it, with in configuration.nix. So I've got to play around with it, but I was kind of hoping to be in NixOS, but I couldn't get it. I didn't have time to mess with this, so I had to reboot and jump on Gen 2 real fast, but it's not a big issue. It's the same thing, so how's everyone doing? Hopefully the music and the sound is okay for you guys. I've been trying to get it a little bit better because I'm tired of messing with it, and I know you guys are tired of having to hear crappy sound. But I'm gonna get here in a second. I'm gonna pull up the. I'm gonna have the Rust handbook on my other monitor, and then we're gonna pull up neovim, and we're just going to make sound is perfect. Awesome. Glad to be here. Oh well, I'm glad you're here. That's cool, and welcome. Yeah, so for a little context about my programming experience and all of that, I do have some experience in C, C++, Python, a little bit of JavaScript experience. Of course, I got a little Haskell experience from Xmonad. Trying to think what else. Some Lua, from neovim and stuff like that. So I don't have a ton of programming experience. This is going to be a whole new thing. Now I have kind of cheated a little bit, and I've been watching some Rust tutorials and just to kind of get a head start a little bit. But yeah, we're gonna be doing this stuff together. Like, and we're gonna make a ton of mistakes, and I'm sure we'll have someone in chat tell me, you know, how bad I really am at Rust. But yeah, we're gonna learn some stuff, and it's cool. Get a little nicotine going. All right. So let me go ahead and hop on the other monitor. Let me go ahead and switch this work scene as well. And it's Rustling. That's the website, right? Yeah, it's Rustling. So if you do want to follow along, head on over to the Rustlang website. It's the official Rust documentation website, and if you don't have Rust installed, which most of us have Rust installed by now, you can install it. It'll tell you how to install it. If you want to follow along in the handbook, then they have a book, and it's pretty good documentation. And that's pretty much what we're going to be following along. Except we might do like our own stuff a little bit too. So let me find. I guess it's under the Learn tab. Alright, cool. Go ahead and pull up a terminal, and then I'm probably gonna make a custom hey, well, I'm just gonna make a custom directory here. And we'll name this I'll name this Rust Projects. You can name it whatever you want. Or I'll just name it Rust YouTube. How about that? And bear with my typing a little bit. If you don't know, I recently switched to a new keyboard layout. I'm using Comac DH and not the standard QWERTY layout. So if I make a lot of typos, it's because I'm still learning, but I have gotten a lot better. So that's also something else. Alright, so we can name it Rush YouTube, and then I will do a I kind of want to split this up, right? Like, because if we do multiple of these streams, like, I don't want... I guess I can name this, like, MK... I'll name this MK... Or... I'll make directory, and then we'll call this, I'll just name this 01. Alright. So now what we need to do is Cargo is Rust's programming, or it's Rust's package manager, right? And so we can use Cargo to make our project for us. So that's what I'm going to do. I'm just going to say cargo, call it init. Actually, let's look at cargo. Let's look up, see how we call new projects. I don't know if it's new or if I don't know if it's init. So if we do cargo / help, we can see a bunch of commands. There's a build command, there's a check command, clean command. Okay, so new. So it looks like new will create a new cargo package, and then init will create a new cargo package in an existing directory. Well, I can just do cargo init then, right here. Invalid character, okay. So we can't do that because we're in a numerical directory. I named it 01. So, shit. Okay, I don't want to do that then. Let me remove directory. We're not going to name this 01. I'll just say, we'll call this like P01 or something. Like Project 1. Alright. And then we can do cargo init. And it should work. Cool. It worked. So, the way that cargo kind of works is cargo will make this toml file, right? So this toml, this cargo.toml file, what that is if we're ever going to put any libraries that we're going to be using, we can actually put those libraries directly in there. And it's almost like a JSON file, if you guys know what a JSON file is. But pretty much it will house like the version of our program, who made it, and it automatically does some Git repository stuff. So I'm pretty sure we have a Git repository in here. Yeah, so you can see if I do ls-a, it automatically does the .git for us, and it has a .git ignore for us. Cargo itself, though, if we wanted to add a new, like a new crate, that's what Rust kind of calls their packages, a new crate. Cargo can automatically add it to this cargo.toml file. And we'll actually be doing that in a little while. But right now, we're going to look at the source. So we have a couple of different directories here. We have cargo.toml, and then we have source. The source directory is the actual main.rs file. And the main.rs file is your main, like, Rust file. That's what you edit and put all your Rust code, and then what you can do, like after you do all your code, you can do cargo run main rs. Actually, I don't even think I have to do main rs. It's just cargo run, and you will see it built it, and then it printed hello world right there, right? So, that's simply how you can run a Rust program, alright, if you're using cargo. Now, what if we wasn't using cargo? How would we run this Rust program? Well, Rust has a built-in, there is a compiler for Rust, and the compiler is called Rust C. So if you do Rust C, now, if you want to manually compile, you do have to specify that main rs file. Okay, so if I do Rust C main rs, you will see it compiled. It was just very, very fast. And if we ls, now we have a main program right here, and we can run it with the /main. And it's the same exact thing. All right. It's a little bit easier using Cargo because Cargo can handle a lot of the just the nuanced stuff for us, like adding crates and stuff like that. I'm gonna try, if I can. Trying to make my fonts bigger on the screen for you guys, but I have screwed something up in one of my configs or something, because I could not remember this keybind to save the life of me. Yeah, I can't remember it. I could do it with the mouse wheel, but guess not. All good. Alright. So the first thing I think we're going to do is we're going to get in neovim and we're going to edit this main RS file, which is the actual code, right? Now, the Rust analyzer, which is the LSP server, it's going to give us some warnings right here, and all this warning is, it's just telling us that we should have a snake case name, but overall it's just a warning. Doesn't really do anything. There is a way to get rid of some of the warnings, and I don't know if we'll get into some of that stuff today, but pretty much, yeah, we can just deal with it for right now. Now, what if, let me pull up another terminal, and this is the only thing that's going to suck about using neovim, but let me get into that project here. So, you can see in this code, there's two I want to make my fonts bigger. Hey, does anyone know how to make your fonts bigger in neovim? I'll look it up in a minute. Alright, so pretty much in this main function, alright, we have a main function, right? This main function is always called. This is the main, this is the function that will always be called no matter what. Every program, every Rust program, I believe, has to have a main function, okay? And you can see right here, this print line, and how it says hello world. Well, if we change hello world, and we can say, we can say hello YouTube. If I can type. Okay. And if we quit that and save it, and now we get over here and do cargo run, you can see it says hello YouTube, because I forgot the E, but you get the idea, right? Now, this is not, that print line That's not a function, okay? That's something called a macro. So Rust is kind of weird. I believe there is a print line function, but they do something called macros. And we can tell that this is a macro because it has a explanation mark at the end, right? So if I get to the bottom of this thing, and just to kind of show you guys. So you can see right here my LSP is saying, yeah, like it's saying it's a function right here. But you can also see, like, it pulls up these macro rules, right? But printline is a, if it ends with the exclamation mark, it's a macro. Doesn't look like there is a print line function. I wonder if we'll ever get into the print line function. But pretty much we can print anything else we want to the screen, right? Like if we wanted to say, hey, we can do, we can do print line. And then we can say, hello, my name is Chris, right? Give it a semicolon at the end. Write it. Come over here. Cargo run. And you can see when we ran it, it says hello YouTube because that's the first line, right? And then hello, my name is Chris. That's the second line. Now, print line can do more stuff than just print text, right? It can print anything to the screen. So we can also say we can get rid of the hello YouTube, right? And we can say, hey, let. So let is how you make variables here in Rust. So you can say let a equals 4. Right? And then we can say, how about let B equals 3. And then we can say, let C equals A plus B, right? And now we can even print this to the screen. We can print the results back to the screen if we wanted to. Okay. Get used to these keybinds a little bit. And I'm pretty sure the way that we print variables is we have to put everything in these like squiggly brackets. So we have that squiggly right there. Okay, and then we do a comma after the quotation marks, and then we say C. Okay, and then we go over here to run it. We can see the result 7 over here. So that's a quick way that you can, you can print variables to the screen, you can print names, you can print anything. The print line macro is designed to let your user see some sort of output, right? Let me check to see how you increase the font size here in Alacrity. So someone said that someone was saying that we there's a bug or something. Let me see if I can do this in Kitty. I do apologize about this, guys. I just want you guys to be able to see, because I'm not... I know my monitor size is pretty... It can be ridiculous for some people, so... Oh my god. I don't know. Like, I'm trying every possible command. Ah! See if I can do it over here. See, it doesn't work on Alacrity. Alright. I'll use Kitty for just showing you guys, like, the results and everything like that. I do apologize. Hopefully you guys can see this now. And if it gets too small, then too big, then let me know. But let me get in that Rust apps, or Rust YouTube, prod. All right, and now if we do cargo run, you can see the results right here. 7. You can see it nice and big, right? Nice and big results. That's exactly what we did over here. There. That's a little bit better. Alright. So hopefully you guys get an idea, though, of like some of the variables and stuff like that. Next thing I think we're going to be checking out, though, and something we need to look at. There's something called mutability. So by default, every variable in Rust is what's called immutable, which pretty means that once you initialize that variable, it can't be changed, or you'll get an error. So, for instance, right? Now we know this computation right here will result in 7, right? 4 plus 3 is 7. But let's try to change one of those. Let's see what that does. So if we do A equals, we'll say 2, right? Well, the Rust analyzer is already going to give us an error. And it says, cannot assign twice to immutable variable. Okay? And if we didn't know any better and we try to run it, alright, let's try to run it, see what cargo says. So you can see over here the same exact thing. Cannot assign twice to immutable variable. Right? So what this means is that once we make these variables, they can't change. However, if we put a MUT keyword, which is mutable, so you put your MUT keyword before the variable name that you want to later mutate, right? Now we run it. We can see that the original results got printed, C, right? Or 7, sorry, now C. And you may be asking, well, how come it didn't get printed 9 or whatever? But that's because this let C equals A plus B was put before we changed that variable, right? So we can even do, so now we could say C equals A. We can do it again, right? And then we can copy all right, we can copy that line. All right. And now you can even say, it will say cannot mutate the mutable variable C, right? Because it already got assigned once. So we're going to fix this error as well, right? And we do that with the mutate keyword again, right? And now you can see that we don't get any errors. Now here's a weird thing. We're getting 5, right? We're getting 5. We're not getting 7. Now, there's something called shadowing, I believe, and I don't know exactly what that is, but the reason it's reading 5 is well, it should read 7 right there, right? That's not. It's reading 5. And I wonder if we yanked this line right here, and we put that line right here. I hate BIM sometimes. I wonder if it will read 7 then 5 if we do it like this, or if it, yeah. So it should read 7 then 5. So there are, I mean, there are some nuances with Rust and how it handles like variables, how it handles like mutability and stuff like that. But that's also one of the that's one of the reasons it's called a safe programming language, that and the way it handles like its memory. But the compiler will complain more than a woman will, or more than a lot of women. If you're a woman watching this, I didn't mean it like that, but you know, a lot of women complain. My wife complains. So the Rust compiler will complain more than my old lady. All right, and yeah, it's just something you have to kind of deal with, and all right. I guess the next thing that we can talk about is constants. Now, what is a constant variable? Well, a constant variable is a variable that will never, ever, ever get changed. Now, I don't understand. The only thing I don't get about Rust is why they have constants and why is every variable default pretty much a constant anyway, right? Because if it's immutable, then it's a constant. It can't be changed. But there is a const keyword, okay? So the const keyword is const. Alright. And then you could do, I don't know. You could do age. And then you have to give it. This is another thing that's weird about Rust. So I'll show you this. So I'll put my age. It don't matter. All right. So keep looking at this format because this is the format of how Rust does their variables, right? So typically you will have either the let keyword or a const keyword or something. You'll have the variable name. In this case, the variable's name is age. Then you'll have the type, all right, the variable type. And this is a unsigned 32. And you can look at all of the variable types and everything, but pretty much there's unsigned 32, there's unsigned 16, unsigned 8, I believe. Then you have the signed versions, and then you got like floating point, you got booleans, which is true or false. You got floating point numbers is like anything that has a decimal. You have true or false, which is booleans. And then you can also do some custom types and everything. So types is a pretty big thing. But the idea of types is like if you don't need all of the like this number right here, right? We don't need an unsigned 32. I don't know how far a unsigned 32 goes in memory, but we'll never hit that with my age. If I live past 255 years old or whatever, then I'm doing something amazing, right? So we could actually just say, hey, we can make this a U8, right? Because a U8 makes more sense in this context. Because I think an unsigned 8 goes... I'm trying to look for the they don't really don't... They're not going over the yeah, the data types. Here, I'm gonna look at the data types real fast. All right, here we go. So the data types, what these are is, so this is a 8-bit unsigned. So yeah, the length is 8. It's an 8-bit number, right? Then you got 16, which is 16-bit number, 32-bit number, 64-bit number, 128 architecture. Then you got decimals, hex numbers, octal, binary, floating points. So there's kind of a lot there. You guys can scope it out, look at it. But yeah. So how would we use this const variable, right? Like it's a constant. You can't do anything with it. Well, you can still print it to the screen if you wanted to, right? Because that's the only thing we've learned so far is how to print stuff to the screen. So remember. And I promise we'll get past this printing stuff to the screen. But I do want to kind of bake this in a little bit, just so we understand like the basics. I don't believe it's like that. But in here, we can even say, hey, like my age, right? My age is, right? And you can see, you can see the Rust compiler or analyzer. It's griping again that these constants should have a upper snake case name. They are correct on this. Typically, the way that you want to do your constants is you want to do an all capital. All right. This just helps anybody else that's using your program. Most of the time, people do this. They put constants in all uppercase. Just it's easy to remember. And they do that in more languages than just Rust. That's a pretty common thing to do. But you can see that we typed in, you know, we have that age, that constant age, and we say my age is 37, right? All right, cool. We printed a constant. Well, let's look what happens. Let's look what happens if we try to change that constant, right? So if we try to change this constant to 22, I wish I was 22 again. Is it gonna let me? No. It's not. It's gonna complain. Alright? Go figure. But pretty much it's going to say could not compile due to one previous error. And it says cannot assign to this expression. Alright? So it cannot, once you've already made a constant, you cannot reassign it. Now, you might be thinking, well, what if we put that MUT keyword, right? That mutability. See what happens then. Alright. So we're going to get 2 errors. We're going to get 1 error that says, can I assign to this expression? We're going to get that right there. And then we're going to get a warning and an error right here that says, hey, you might want to declare this to be a static variable, or a you know, with the let keyword and everything. So with normal variables, just with the let keyword, right? We can reassign variables as much as we want to. All right. With the constant, or with this const keyword, once we have a constant variable, we cannot change that variable. All right. So I can't think of any reasons why you would want to use const at the top of my head. There are reasons. I can't think of anything right now. I'm sure I will later on. All right. So we learned about const. We've learned about print line. We've learned about some about MUT, or the mutate keyword there. Now let's learn about shadowing. And this is, again, this is one of the subjects that's kind of hard to understand. because it's kind of hard to talk about. By the way, if you guys have any key like questions or anything during this, or if you guys just don't understand something, but you know, if you think I could help you, feel free. Just you know, feel free, and I'll do what I can to kind of answer any questions for you guys. All right, shadowing. So there's something called shadowing here in Rust, and pretty much it's where you can use the same name. All right, we can use the same exact variable name, and only one of them will get used. All right, so I'm going to run through a little example here. So we can do let's look at this in action. Right, we can say let x equal 5, okay? So now x equals 5, right? We're not going to mutate it, x equals 5. All right, and then we can say let x equal x plus 1. Now, you may say, well, shouldn't this be 6? Right? Because x plus 1 should be 6. Let's figure this out. Let's see what it does here. And we can also put another one in scope. X equals x. Now this is kind of funky. Alright. And we can print line. Alright, we can print line, and we'll say the value in this scope is, alright, we gotta make the little thingies right there. That's how they have it printed out. Okay. And then we'll do the same thing down here. Hey, what distro am I using? This is Gentoo. Yeah. I'm usually always running Gentoo. Now, I was gonna run NixOS tonight, but OBS is kind of being a pain in the butt, so I gotta look at that. All right. Oh, I know I did. So what should happen on this, is we've declared these outside of the scope, right? And if you don't know what scope is, scope is the things inside these curly braces, right? It's called a scope. And it pretty much says that these are now going to be like local variables. So the idea is that once this section of code right here, these two lines end, the memory from this will, it'll vanish. Yeah, Nix is cool. Nix is very cool. All right. So telling from this line right here, we should set it should be, well, x times 2. X is 10, right? Or x is going to be, x is 5. So it's going to be 5 times 2, which is 10. So this one should be 10, right? And this one should be 6. Chaos says, think it's kind of similar to Python. Like you define a function and everything within it is the scope of the function. Yeah. So you have like your main function, right? Oh, hey, Krufu. What's up, buddy? So you have, you got your main function right here, and then you can declare everything inside there. So this should be 10, right? And then this one should print 6. See what it actually prints out. Oh, I got that all wrong. It's 12. Not 10, Chris. 12. Yeah, because x times. That's throwing me off. I get how this one's 6, but how's this one 12? Because it's the same variable. Okay, so this is the shadowing thing, right? So we can do another one. We can say x plus, I don't know, just say plus 2. Alright. Now, if my math is correct, the first one should be 14, right? And the second one should be 8. $16 and 8. But you also notice we're not getting those errors, and we don't even have to put the mutable keyword in front, right? Which is kind of strange because I understand. I don't like shadowing is kind of weird. So it says taking any uses of the variable name to itself until it, okay, blah, blah, blah. We can shadow a variable by using the same variable's name and repeating the use of the let keyword as follows. Oh! Gentoo best distro long and merge times, especially installing KDE. Yeah, I mean, KDE is a big package. Alright, so it says as long as we adhere to the let, the way that we put the let, then it'll be shadowed and it won't be, it won't throw us off any, like it won't, we don't have to mutate it or anything else. But let's try this. Like if we did let y equals x plus 2. No, because it's in the same let. It's in the same let. Okay, but what if we do let x equals 10 now? You came very late. What are we doing? We are learning some Rust. Yeah, we're gonna try to run some learn some Rust, and we're doing an okay job. I think we're getting it. It's gonna be hard. I like learning about difficult things. All right. So do we see the problem? Right? So as long as we use that let keyword and reassign with the same variable name, it's going to let us. It's not going to throw us off any errors. Excuse me. But if we don't use that let, then it's going to say, hey, we cannot assign twice to a immutable variable x. Right? Let's say if we put let in front of it, if that would comment out, right? So if we do let x equals 10, that error is completely gone. Because now it's being shadowed. That's what they call shadowing. You like learning difficult things, me trying to understand. Yeah. Yeah, that neovim setup was something else. Alright, so if we didn't put let right there, right? And let's say if we wanted just to change this, like, later on in the program. So if we did x equals 10. Alright. What we could do is we could put the mut keyword, right? For let mutable. And we might have to do it for all of them. I think we'll have to do it for the first one. Do not assign twice to an immutable variable. Okay. We're gonna figure this out, guys. So if we put mut right here. I don't know why it's not. Remove this one, remove this one. Okay, I get it. So you wouldn't have to put it on the first one and second one. You would just have to put it on the last one if you was want to mutate that variable, right? And now we don't get any of those errors. And if we do a cargo run, now we can see the results. So that's a little difficult, right? That's a little funky. But you can see the Rust analyzer does a very good job, and it tells us exactly what we're doing wrong, right? Like it's saying right here, like this is not an error. The orange ones are warning signs. So it says value assigned to x. X is never read. Maybe it is overwritten. Or X is never read. Which I don't see how it's saying X is never read. Because it should be right down here. We're reading it right here. Well, we're reading it to the screen. Right? Alright. So I think we kind of got the shadowing stuff. I mean, it's going to trip us up sometimes. But that's the gist of it. So, as long as... So, you can use the let... If you put let in front of the same variable name, right? You will not get an error if you use the same variable name. However, if you do not, then the object needs, or the variable needs to be mutated, right? So one more time. If we do x equals 5, right? And then we do x equals 10. Okay? We're going to get an error, right? Because we cannot assign twice to a mutable variable. However, right here, if we put that or if we put the mut keyword for mutable, right? We're not going to get the error because now it's mutable. Or if we wanted to shadow, that x right there, we just put the let, right? So that's the TLDR of how to use it, at least. All right, next. Let's go next. All right, so, and another thing with mutable differences, with mutability, and shadowing is that because you're creating basically two different variables with the same name, they can even do different things, right? So we was just using X right there, for instance, but we don't have to, right? So one of the little examples that they have is we can say we'll just say let spaces and this is fine, okay, but we can also say let spaces equals space dot length, or spaces dot length, right? And while these technically are the same name, they're actually two different variables. Alright, so this is getting the length of... I think this is getting the length of spaces. And then this is like the physical like space between, you know, two words or whatever. Alright, so I do want to cover some data types real fast. This is some of the more boring stuff, but it's pretty important. We should all understand data types. But remember I talked earlier about unsigned 32-bit numbers, 16-bit, 8-bit numbers, floating point numbers. So I want to show you some of those. Excuse me, I want to show you some of those numbers. So, like we can say, let x equals 12.0. Okay. This is a float, right? Because it has a decimal. Okay. uh, we can say let t, and we can say true. All right, this is a boolean. So this means true or false. Okay, boolean just means true or false. Okay, that's all it means. There's like whole numbers. Okay, so you can say let a, and I'm just using these variables as whatever. These variables can be whatever you want to give them. So like a whole number would be just 10, right? So I don't know what it is by default, but I'll just say it's a U8. Now we can even specify. We can specify what type of number that we want it to be. Okay, and we do that with that colon. Remember, we saw that colon earlier. Okay. So now I'm specifically saying this is a unsigned 8 integer number. Okay, we can even do, we can just do F, okay, and we can, what about, we'll make this one U, I don't know, U32, something big, right? Something monster, right? 2,000, big number. So, and I'll just say this is a unsigned 32-bit integer. Okay. There's trying to think what else. There's a character. Okay. So there's something called a character. So we can say, we'll just say D, actual, we'll say C per character, right? And a character, you have to tell the computer that it is a character. Okay. Pretty sure that's how you would do it. Yep. Hey, Teak 45. What is up? What's up? How are you? So, if you're just not getting here, pretty much we're learning a little bit of Rust today, or tonight rather, and yeah, just trying to get our brains a working. Alright, but hopefully you understand data types. Now, oh, well, the last data type I want to cover, which is a pretty big one, is strings. And I'll just call this S for string. Okay. So Rust is, I think they call it like it's strict. It's strict on their types, right? Like their data types. Like in Python, for instance, anything can be anything practically, right? And Python just kind of understands how it interprets everything. Like if it's an integer or if it's a number or whatever, right? Rust is more like C and C++, and the fact that you have to, when you declare your variables, the compiler wants to know what kind of data type we're using on this particular variable or whatever, right? Like it wants to know. So, and these ain't all the data types. I'm not going to cover all of them because, quite frankly, I don't know all of them, and it's not even showing all of them in the handbook. But hopefully, this gives you an understanding of like some of them, right? Some of the common ones, like you'll use floating, you'll use true or false a lot, right? And I guess we can make this more concise. So we'll say bool, right? So that's a boolean. And then this one will be a float. Guess a capital F on that float. No, it's still, I know a float has a data type. Or, no, okay, so you have to, it's a F. It's prefix, sorry, it's not a float. It's called an F, like 32 or F64. But you guys get the idea, right? Like, it's a floating point number. That's all it is. All right, so hopefully that gives you an idea. Get an error on this one. All right, let's cover something else. So we understand data types. Well, most of them. You just have to, what you have to understand is when you declare your variables, okay? When you declare your variables, Rust wants to know what I'm gonna... Dude. Like, one of my keybinds kind of ain't working. And I don't know why. See, visual line's working. I don't get it. I'll have to... I'm gonna have to mess with this again a little bit sometime. Alright. So the next thing I think we're going to cover will be functions. Actually, that was basic data types. Alright, that was the basic data types. We still got to cover some data types. Alright. The next one we're going to cover is tuples. Something called a tuple. Now, whoever was talking about Python earlier, you probably understand tuples, because I believe tuples are a part of Python. And I believe they work the same exact way. I'm pretty sure. Okay. But pretty much the way we do it is we say I'm going to say X for instance, right? Let's see how they're doing it. Never really messed around with tuples before. Even when I messed around with Python. Could have. But, bear with me a little bit. So I can kind of understand this. So, what we're doing right here is we're declaring. Okay, we're declaring our data types, right? Remember how I said that we're just going to do all I32 data types. Okay, we're just integers. Okay, and now we can give these, we can give these some actual values. Because these are not values. These are data types. So we're saying what data types we want this tuple to have, right? So we can say like 300, we'll do 400, and we'll do 2. It don't matter, right? And let me... just so people that's coming in can understand. Tuples or tuples. Okay? So... the way that we access these variables, now we can print out the entire tuple, right? So we could do print line and all right, we can do a print line. So we've seen this earlier. This is how we print something to the screen. Similar to print in mostly every other programming language. Okay. Now it should print the entire tuple. Oh, we're getting an error here. And that's because it doesn't know format display. Let me think. Alright, let's try to access a like a field, right? See if it errors out now. No, it's not going to. Alright. So I'll have to learn how to print each individual tuple. I don't know how to do it, apparently. But you can see if we do x dot 0, this is the first field. This would be x dot 1. This would be x dot 2. For you guys, tuples are awesome. Yeah, so for you guys that's new to programming or whatever, in programming, the way that numbers are kind of set up is everything starts at 0. It doesn't start at 1 like, like English or y'all's native language. It starts at 0. Alright? So the first thing that's always in a list is element 0. The second thing will be element 1. The third thing will be element 2. So in this instance right here, that x dot 0, that's representing this 300 number. X dot 1 would represent the 400 number, and x dot 2 would represent this 2. All right, and we can verify that. What I'm saying here, we can verify if we did x.1 access that field. Okay, and we did cargo run, so you can see we get that 400 printed out right here. The tuples get deconstructed to structs under the hood with the number or index as the field name. Oh, okay, okay. And we can even, if we wanted to, right? We could even do, like, we can say I'll just say let 2, right? Let 2 equals x dot, that x.2 field, right? And now, this 2 right here, this 2 variable, is actually this tuples 2, right? Okay, and we can verify that as well. All right, so we can do and I'll just print out. We print out 2 right here. Okay. So you can see it printed out 2 right here. All right. Hyro, if I'm going a little slow for you, buddy, I apologize. I'm just trying to make sure I understand this as well as explain it the best way I can possibly explain it to new people. Because I know I'm going to run into some stuff I don't understand. Alright, that's the basics of tuples. Okay, it's just a way to group data together. Later on, there's a way also to print out the whole entire tuple. I don't know how. There's a way to format the string so that way it gets printed out properly. I've seen it before. It's percent something, right? The percent D? I don't think it's percent D. I think I'm thinking of C or something. Hey, how do you print out the for debug print? How do you print out for debug? You know? So there's a way. So with the regular print line macro, you have to format some of these variables in a way that it'll be printed out to the screen. There's a debug print. There's a debug print line that you can pass it, and it's a little bit more forgiving in terms of what you can give it. Yeah, that's it. That's it. Thanks, dude. What's up, Darth? What's up, bud? We're learning. We're running some Rust today, Darth. We're putting our thinking caps on. Yeah, that's it, bud. I appreciate that, Pyro. So it's ugly. It is ugly, folks. But it works. So now you can see. Holy crap, Darth. Oh yeah, that's right. You're 6 hours. Right? 5 hours ahead of me or something. Alright. So you guys can see the reason we're not getting that error. So let's write this again. Okay. So you can see, when we try to print out this whole entire tuple, just using the regular print line function or macro, it's gonna give us an error, right? It doesn't know how to format the text and stuff in order for it to, we can see it through the console, right? However, if we use the second method, which is the debug print macro, and we pass this colon question mark, that's telling it that it's going to be formatted using the debugger, essentially, right? It can print. Oh, you're working on a project with React? Sick, dude. How's that stuff coming along? I know you've been working a lot on it. All right. So now when we run all this, we can see that we get everything in the tuple right here. So we get that 300, we get that 400, and we get the 2. Okay? So there's tuples in a nutshell, essentially. Nothing to it. It's just a way to put multiple values with a variable and to construct data, as a data structure rather than, just having one individual variable. It's a CV builder. Just getting started working with state. That stuff's confusing, bud. Like, state is confusing. I don't know anything about, I'm more of a systems guy. I don't know why. I don't even like systems programming. Like, visually, it's kind of cool working, I guess, with web stuff because you can visualize it, but, I don't know. Alright, next thing we're going to talk about is arrays. Now, arrays are not only, if you've done any programming in your life, almost every single programming language that I know has arrays, right? Or something like arrays, maybe vectors or something. But just like that, Rust has those same exact concepts, right? And it's just a way to make a collection of variables, or yeah, a collection of data, right? That's all it is. All right. So the way that we do array types is we can do let x equal, okay, and now we just give it, all right, and we can say just 4 here. Nope. I'm wrong on this one too, ain't I? Damn. Alright, it's this. My bad. That's not it. It's this. Too many data types, dude. Alright. Now, of course, Rust Analyzer's griping because we didn't prefix it with. And of course, we can give this with the array. I think it has to be the same exact data type. I'm pretty sure in the collection. Alright. Also, it looks like arrays are not, they're fixed, right? You can almost think of these as like a constant, collection, okay? I don't believe that we can add or take away from arrays. Now, vectors, you can. All right, I'm gonna look at their example on some of this stuff. But we can even do like we can do something like this too. Like we could say int months. Okay, and these can be anything, right? So we can say like Jan for January, right? We can do February. And I'm not going to type all these out, but you guys get the idea. Isn't immutable array just a tuple? Well, it would be immutable array? Well, I think arrays are kind of always like immutable. Now, if you were saying if they was mutable, then I would think that would be more like a vector, right? Because vectors you can add and take away. I don't think you can do that with arrays. Pyro probably knows more than I probably do a little bit. All right, but you might be asking, hey, why use arrays instead of a tuple or a vector? Well, arrays are good when you want. Arrays are good when you know when you know how many elements are going to be in that collection, right? And it's never going to change, right? So for instance, like this, right? Months. We know there's 12 months in a year. In most countries, I know there's a couple of the other countries there's not. In most countries, it's 12 months in a year, okay? Now, which means that using an array here to declare all the months and putting it in this collection called months kind of makes sense, right? Because we're not going to add stuff to it or take stuff away from it. It's there. It's not changing. So in their example, that's a good way or a good reason to use arrays versus versus a tuple or a vector. Now, we can also do something like this, and this is ugly, but we know just by looking at this that this collection is a collection of strings, right? Because you can see, I mean, we got a bunch of string types here, okay? But what if these were numbers, right? You can have a mutable array, but the size is fixed. Oh, okay. So whatever size you give it, it's 100% fixed, right? Like, it can't never change. So we could do something like this, right? And then we could even do... I'm trying to get used to the syntax. Man, some of the syntax is weird. If we want to say what kind of a data type this is, we could say unsigned 32. Alright. So what we're doing is we're explicitly saying that, hey, we have this month's variable, or this month collection, that's going to be an array. There's 5 elements in this array, so we can see that 0 through 4, right? All elements start at 0. That's what we talked about earlier. And then there is our 5 elements right here. Okay, and we can access these, just like we can a tuple, right? So we can say let A equals all right. So now A. Well, let me change this number because this is confusing. We'll call it 30. So A now is 30, right? Alright. So we should need to put the debug in here. If we run this, all right. So if you wanted to access, that element, that's how you would do it. Trying to think of something else we could do with arrays. We can call. This is kind of get into like objects and stuff, but we can call this month's collection, and because now it's an array, it does have some methods built into it. Okay. Multi-dimensional array. Yeah. I think you can have multi-dimensional arrays. Let's do... We could do, like, let's see the length. Let's see if this works. I'm not sure. So we could do months. Give it the length function. Okay. And now, an array of arrays. That shit gets confusing, man. Alright. But we could print out the length if we wanted to. If I can type. Oh yeah, I didn't put a comma. Haha. What? All right. And if we run, you can see that the length of this array is 5, right? Per single. Okay, for single name variables, you can just do print. Okay. I'll try to put that in the bank up there. All right, but you can see pretty much like what we can do with arrays, right? Like we declared 5 elements right here. All right, we assigned A to the first element in this array. Length right here, we're getting the length of the array. So the length is 5 elements, right? Because we told it, hey, we're gonna only put 5 elements in this array. So this length function or method will put that number, that 5, into this variable, okay? And then we're gonna print out that variable to the screen, and we can kind of see that at the bottom right there, right? All right, now we're gonna put this into action a little bit. All right, we kind of understand what's going on. Kind of understand. Gonna get rid of this one. Now we're gonna do something that we haven't really done yet. We're gonna get input from the keyboard. Alright. So I can say use this input output. We're going to use this module, right? Remember how earlier I said that cargo, with the cargo package manager, we could have other crates and stuff like that. Well, right now we're not using any crates, but we are using, well, I guess this is considered a crate, but this is the standard input output crate. All right, but this is built in to Rust. Like we didn't have to specify this in cargo or anything like that. All right. So this is where Rust gets a little like some of the syntax gets a little funky, right? So we're just gonna say, hey, print line. Okay. And we're gonna say, please enter a number or array index. I am looking at the guide or the book, but I pretty much understand it. Most of it, anyway. Dude, this so if you want to know why I'm kind of struggling with typing or whatever, I'm using a different layout. I'm using Comac DH. I'm not using QWERTY anymore, and I'm having to like switch layers on my keyboard. I got a programmable keyboard, and so it is taking me a while to kind of learn some of this stuff. Just letting people know so they don't think I'm a total idiot when I type. So we're saying index, and then we're gonna say this is gonna be a string. And we're gonna do this new function right here. And we ain't really talked about this, but we're making a mutable index, right? So this is just a variable. And it's going to house this new string. And I don't know what the new keyword is. I mean, I know this is a string, but we'll learn that later. But we can say IO, and this is where the funkiness of the kind of the Rust lang. So the way you got this typed out, and this kind of makes sense, is we're grabbing the input output stream. We're grabbing standard stdin, which is the standard input. That's how you would get input from the keyboard, right? And we do read line, and this is what actually reads the line. We ain't talked about this yet either. We will. Oh my god. See, I got some of these. I got some of my like special operators on a different layer. Okay. Another dot. And we can say expect. And then we can say failed to read line. Okay. Yeah, you might be right. You might be right, Darth. Alright, but what this is doing, we're saying, hey, remember how we imported the standard input-output, right? So we're saying, hey, standard input-output, read the standard input function. This function has another function called readLine. We're reading the line. Okay? Oh, okay. Yeah, but we're reading the line of we're saying that this, because this index is mutable, so we're saying it's mutable when we do our input. I think this is a pointer or a reference. So we haven't learned about those yet. We will, because that's pretty big. And then we have some safety here. So if we cannot get any, like, this is for error handling and stuff like that. So if we can't read the line, then what's going to happen is it will say fail to read the line. And you'll see this a lot too. There's a lot of like there's a lot of error handling for you built right into Rust, which is fantastic because some of that stuff is a pain in the butt. Alright. So now let me type this out and we'll go through this too, from what I understand of it. How long did it take you to learn Rust, Power? All right, let elements equals ah. Yeah. Let me do this last print line, and we'll talk about this. The value of the element at index Yeah. The syntax is a little clunky. That's what I'm kind of like. I'm fighting with a little bit. I mean, it's cool, but it's a little. It's just a little different, right? All right. So pretty much what this is doing is we're making an index of usize, okay, and then we're trimming off. First, we're trimming off, I think, the new line character. Then we're parsing it. All right. So we're making it like readable. And then it says, hey, if we don't enter in the right index, then it's going to say index was not a number, right? So we're making sure that what we type in is a number and not like a character or a string. Oh shit. I know what I did. What am I doing? There ain't no A. There's X. Get rid of that. Do I not have the macro set? No, I do not. Move that over. Oh, and I need a semicolon. Still getting an error. Let me run this. Cargo. Connect compile, blah, blah, blah. Argument never used. The value of. Use size int equals index trim dot parse dot expect index was not a number. Okay. Let elements equals x index. Argument never used. Let's see something. Please enter array index 2. You're passing 2 arguments when you don't use it since you're using the interpolation of the index variable. Try extending the string to include the elements and remove the second argument. Oh. What I don't understand though is it let's type in 100. All right, so 100 is gonna panic, right? Because the we're out of bounds of that array. The index is out of bounds. The length is 4. Okay. Let's try 3. Value of the element at index 3 is... Oh, okay, okay. I see what you're saying. What's up, Seeker? What's up, dude? We're learning some stuff here. Or trying to. Like, I'm trying. Ah, there we go. I know what I did. You need to learn Rust? Well, come on in and join us. We're rocking, man. We got Pyro who's in here. He's telling me or helping me out. We got Darth. Darth is he's a good web developer, and he's learning a bunch of cool stuff. Shit up. I'm doing it on stream. I mean, right now is the time because, you know, like, if you screw up, it doesn't matter. As long as you learn something from it. But you can see, like, and we're going to screw up. Big time. That's cool. It's cool because you actually learn something, you know. So. Pretty much what we're doing. And, oh, yeah, we just started too, Seeker. So, yeah, as long as you got Rust installed, you can follow along if you want to. You still learning Python in your spare time? So pretty much what we did is we made a collection of arrays with X, right? We gave them these sport elements. We told the program, hey, enter a array index, right? So we'll walk through it. as we're running it, right? So if we type in 1, 2, 3, or 4, okay, what's going to happen is it's going to be able to parse all of that stuff, right? And but if we hit 5 on up to 1,000, right? It's gonna say we're gonna get an error because it's gonna be out of the length of the array index, right? Now, if we typed in a string, so let's type in a string. So let's type in a name here. So we'll say my name Chris. Watch what happens. Type in a string. We're gonna get a panic, okay? And we're gonna say index was not a number, and you can say index was not a number right here, right? So it parsed our information, it parsed our numbers, right? And it said, hey, that's a string. I was expecting a number. It's not going to work, right? Because it wants a string, not it wants a number, not a string, right? And then right here, what we're doing is we're saying, hey, take that element. So take that number, whatever we give, or whatever number that we give, right? Go find it in this list up here. Josh is in the house. What's up, man? Compiler report. That's awesome. Yeah, we're doing some Rust, bud. And we're getting some people in here. Awesome. So, if we did 100, right? It's gonna panic. And if we do 4 is even gonna panic because there's only 3 there's only 3 elements, right? Because remember, everything starts at 0. So if we do 0, the index is 1, right? But you guys kind of get the idea. And this is going to, if we print out, if we hit 3, we should get 4. Okay? That's how it works. So pretty easy to understand. I mean, the syntax is goofy. Like, this syntax is weird. And you can write out, so you can write, this is how I wrote it out. Or you can write it out like this. Like, where you have everything all on one line. I personally think everything on one line is a little bit harder to read and to understand. But you can definitely do it like that. It doesn't matter. Okay? Pamina, what's up? What's up? Alright. So the reason it's going back every time is because I have my formatter. It's auto formatting for me. Alright. Alright, we're gonna get into functions. I want to know what's going on with visual mode in my damn editor. Okay. Now I'm going to keep this use input output up there because we'll probably be using it. I'm going to get me something to drink. Alright. And when I come back, we're going to learn about some functions. and how we use those, and yeah, what we can do with those. All right, so I'll be give me like 2 minutes. All right, we are back. Talking about some functions. All right, functions. So what's a function? Well, a function is essentially just a block of code, right? And we've already been seeing one function, this main function, right? All right. So you got main down here. That's the main function. That's the function that always gets ran every time a Rust program runs, right? But we can create our own functions too. Okay, so we give it the the FN keyword, and so we can just say test. Okay, and then we can say whatever we want right here. Right now we'll print something. Okay, and we'll say hello from test, right? And then we can come down here to this main function, right? And we can call this other function. All right? So now if we run this, okay, what should happen is that we'll just get this line, hello from test. And you can say hello from test. That's what happens. Now, ideally, your functions are going to do more than just print something to the screen or whatever, but it's an example, okay, of how we can actually use functions. Alright, and you can do anything inside your custom functions that you want to. Ideally, you want to keep functions kind of small. Alright, you want to have your custom functions kind of small, and ideally you want them to do like one thing, right? Like one pretty good thing, alright? And ideally do it pretty well. You don't want one function that do like a million different things. Like that's not good practice. What's ideally one thing, and keep them relatively small because you can write more if you want to. Alright, if you need another something else, right? Now, we can give these functions parameter, something called, so we're going to talk about arguments and parameters, right? So a parameter is some variables or some information that we're gonna pass to that function to do something. So let's see an example. I think I'm saying that right. So in a So we can say, we'll say x is, and then we'll say x, or x, right? And now, in Rust, you have structs and imply blocks in which you can attach methods to any type, basically. Oh, okay. I've seen the imply thing. I've seen that before. I've never messed with it. The reason I really just know about functions, like, and how they work, is from other languages. Most other languages, it's almost the same exact concepts, right? That's why, if you guys ever see other programmers and they go from one language to the next and the next, it's not because they're somehow smarter. It's because almost every language borrows stuff from each other. So once you understand the concepts, learning the different languages it's not a big deal. It's not hard. You'll have to learn the syntax. The syntax is different, but the concepts will be basically the same. Night, Darth. Thanks for stopping by, bub. But yeah, the concepts will always, they'll just be the same, right? Now, we're getting some errors, right? And this error is saying, hey, you have a parameter up here. You have this parameter x, but you're not passing any argument to this parameter, right? You're not passing anything to this parameter up here. All right? So what we have to do is this function takes a integer unsigned 8-bit number, right? So we have to give it what it expects, right? we have to give it that number, and we can give it any number we want to, as long as it's a 8-bit integer number. Now you can see that error goes away, right? So if we do cargo run, we can see now x is 4, right? If we wanted to make it, I don't know, make it 10, we can do that. Whatever we want, right? Boom, x is 10. So that's pretty much how you have functions, right? So you can have a what's called a void function, which is essentially a function that doesn't return anything, or a function that doesn't take any any arguments, right? Or you can have a function that does take arguments. You can also have a function that returns something, so it does something, right? It returns something back to the main function, or to whatever function that you call it from, right? And the way we do this, now this syntax is a little funky, so bear with me. But I believe it's like this. And then you tell it what we're going to return. So, okay, we're going to return a U8. Okay. Trying to figure it out. Do we need the return? I think we do have to have the return keyword here. So I'll just return x. No, you know what? Here's what we'll do. X equals x plus 2. Right? Do that. Then we'll return it. So return x, right? Now, it's returning something back. It's giving something. It's doing something, and it's sending it back, right? So now we can do let. We'll just say number. Let num equals test. Okay. And then we can print line. Okay. And we'll call this num. If I did this right. Oh, because it's... Cannot mutate immutable variable. Okay, I gotta figure out how to do this. See, this is the problem. This is one of the issues with immutability and the mutability of stuff, right? In another language, would probably 100% work, but Rust is kind of finicky because it. You know what? Just to make this simpler. We'll be passing immutable stuff later, but to kind of learn this, what we're actually doing. If you wanted to, you could drop the return keyword and remove the semicolon, and it would automatically return the last value in the block. If you All right, give me a second. I'll look at it. So I could just do like MUX. I don't know, 5, right? It doesn't matter. It's just an example, right? If you want to, you could drop the return keyword and remove the semicolon. Okay. So, Pyro is saying we could write it like this as well. You know what? I get it. I don't like it. I have a like some of the C++ background. Like I have a C++ background a little bit, and I don't like that. It's too like it throws me off. I get it though. It is a shorthand and it's nice, but and you guys feel free to use that way too if you want to, but I don't. I like having the return keyword, even if it is a little bit of extra typing. It's just like a reminder in my brain. All right, but pretty much what's going to happen is this function is going to return. It's going to return 5, right? Because x equals 5. So it's going to return 5. It's going to put 5 in this number right here, right? And we're going to print this number to the screen. It's mostly useful in closures. Oh, okay. Okay, so if I can type and run. So you can see right here, we get 5. Now we are getting some warnings because of standard input output stuff up here. I wouldn't. There. Now it'll stop whining. But you can see we get 5 right here, right? So that's something that you can do as well with functions. So hopefully that kind of gives you an idea of like, so you can get data back from a function. You got arguments, parameters, or parameters, however you want to say it. Okay. Your functions should be small. They should do something. Okay. You want these to be like a verb, right? You want these to do an action, right? So I know we just wrote test up there, but ideally you want them to, to do something. For instance, I'm going to rename this and I'm going to rename it to add. Okay. And I'm going to test out my own knowledge, and I'm going to make an add function. So I'm going to make a function that adds 2 numbers together, and it's going to return the value. It's going to return that value back to the user, right? So we can add so I'll do X. No, I'll do A. And I'll just call this a U8. And a B. Okay. U8 as well. Okay, and it's going to return something. It's going to return a U8 as well. Okay. And we're going to say let X equals A. A plus B, right? We're going to return X. And now when we call this, we're going to call the 2 numbers that, well, we got change our function here. We got we're gonna name this. We named it add. Okay. And we want to like 1. I don't know, 1 plus 2. Right? And now it should add it together. And you can see it did. It added it together. So what if, okay, now we learn how to do that. Now we learn how to do that. What if we wanted to run this function again? Right? Like we want to run it again with some new numbers later on down in our code and whatever, right? Well, okay. So we can make this number here. We can make this mutable, right? So we can use the print line function again with it. We can also make this A right here. This A has got to be mutable. You know? Almost makes me want to go back to QWERTY. Almost. Alright, so that mutable A, and then that's going to be mutable as well. Right? B. And now we can reassign number to the add function again if we wanted to. We should be able to. Okay. And we'll say 4, 5. Add those numbers together. Right? And then print line. Number. Right? And we shouldn't get any errors. Let's remove this mutable. Alright, but you can see it worked again, right? I don't think you need to add the mutable keyword to your parameters to reuse the function. Oh, okay, because is that only because we just have to make the number variable, we have to make that mutable, correct? So this is a pretty kind of tough concept to understand, right? It's like when to use mutable, when not to use mutable, okay? But this is why we practice. All right, and we got 9, and of course we could, you know, we can make other functions as well, a subtract function, a divide function, all of that stuff, right? And we would have a calculator, essentially, right? Like you would have a calculator. Let me look at the... Yeah, num is the only one value you're changing. Oh, okay. But if I was changing something in the actual function itself, then I would, right? Like earlier. when I was changing the number and adding it together. Just trying to make sure I kind of get this too. Yeah, that would have needed to have a mute keyword. Okay, okay. All right, and you will see functions a lot, like, and I'm talking, I mean, get used to functions. Okay, okay. Yeah, get used to functions, guys. Like, you will use functions a lot. They're also sometimes called methods. Depends on how you use the function. They might have a name method. They might use the name function. As far as I know, Rust is not a object-oriented programming language. Which, in most object-oriented programming languages, methods are kind of called functions if they're not part, or functions are not part of the class. Methods are part of the class. So there's kind of certain rules. They're all the same shit. They're the same shit. Okay? You call it, you pass it in what it requires or whatever, and it works. Or it's supposed to work, right? Or when you create your own, just remember that, you know, if your functions require a parameter and they require certain data type, then oh, okay, okay. All right. And what I mean by that, so you see your function requires a U8, two U8s, and it's going to return a U8, right? It's going to return a U8. So if we did, let's just call this let fail. This is going to fail, but I want to show you what it would, you know, what it would do, or what it would say if you didn't pass in the right information. So if I wanted to give it a string or a character, like let's say I was wanting to call this function and I gave it I want to give it some characters, right? Remember, the single quote is characters. And what about if the second one? I don't know. Second one, I wanted to give it. Let's give it a string. Name. Right? This is gonna fail. I mean, but this gives you an idea. Right there. Expected a U8. It found a string. But there's actually two errors because, you know, and cargo would, you know, it would gripe as well. But cargo does a very good job, and it tells you, hey, you know, this is what's going on, right? So it's saying it found a string. It expected a U8. It found a character right here. Character. It found a string right here. So cargo, the Rust compiler, Rust C, lets you know, it will tell you what's going on, okay? I keep saying cargo, but it's Rust C that's doing it. Cargo is the package manager. All right. And unlike other languages, Rust does a fantastic job at runtime, well, even before runtime, of letting you know errors. That way, at runtime, there's not that many, there's not that many bugs in your application, which is awesome. I wish more languages, like, it's gonna gripe, and it's gonna gripe to high heaven. It really is. But the code that you write will be safe, and that's the important thing. I think that's probably about it with functions, honestly. We'll be dealing with functions quite a lot, though. And functions can do whatever you want them to do. They could return a string. They could return a number, a character, whatever, right? They can even parse. You might want to parse a JSON file or something like that, for instance. And they could do that. All right. Let's get into comments super fast. So this is a comment. All right. All right. Whatever you type in after these double slashes does not get read by the compiler when it goes to compile the your code or whatever. Okay. So, and it's good practice to comment your code. So adding, I'll just say adding 2 numbers right here. Especially if you write a complex statement or something and you want to be able to remember that, in years' time. Or like, you're like, hey, what's this code doing? What's this doing? Well, make a comment. Control flow. This is one of my. This is something that's pretty cool. So what is control flow? All right, we're gonna get into this. All right. Control flow. Control flow pretty much says. I'm gonna type it out in kind of English, or as we would talk, but then we'll do the actual code. But control flow would be something like this: if something is true, like if something is true, right? Then do something else. Right? That's what control flow essentially is. Or if it's false, do something else. Right? It's how your program decides, based on the input that it receives, what it executes, right? Because you can't always expect that the user to put in exactly what you tell it to put in, right? You can say, hey, input a number in because it doesn't receive a character, and the damn user will put in a character just because, right? Like we do that stupid stuff, right? So with control flow, you could have it say, hey, the user inputted a string or a number or a letter, okay? And we don't want that, so let's let the user know, hey, we don't want that, right? That's control flow. Also, there's something called a loops, right? So loops, we want to iterate through something. So maybe we want to iterate this collection, you know, and see what all this collection has. We want to count to 1,000, right? For whatever reason, right? We want to do the alphabet for whatever reason. Those can be done by via loops, okay? Or if you're making a game, okay? If you're making a game, you don't want the game to end immediately, right? You want the user to be able to, you know, to exit the game properly. Well, okay, the game will continue running as long as it's inside of like a running loop, okay? But as soon as the user enters something that you've told them to exit the game, then the game will never stop, okay? So we'll get into it. It'll make a little bit more sense. All right. So let's just say let x equals 5, okay? And then we'll say if x is greater than 5, okay? Then we'll print out this print line. I wish I could hit tab and just go down in that function. Probably need to do that in the next video. I'll work on this config some more, so this will be a little bit faster for us. All right, print line. All right, so x is bigger than 5. All right. Else, right? Because if we have an if, more than likely we're going to have an else. Not every time, but we would. Okay. We'll do the same thing. But this time, we're going to say x is smaller, right? Because this is a, you know, this is going to be like a conditional. So x is smaller. Okay. Funky syntax, but let's run it. So x is smaller. That is the less than, right? If x is less than 5. All right, let's turn this though. Let's see. Let's make this 7. I think I got these conditionals wrong. I think so. I got those wrong. I need to go back to math class. Alright. And this is executing. This is executing because x is bigger than 5, right? X is 7. X is bigger. I mean, 7's bigger than 5, right? So now, what if this value is 3? Alright? What if this value is 3? Okay? X is smaller. The top portion never gets executed, right? So that's a conditional, right? We just saw that. Like, you know, if something is bigger or if something is doing this, then we do this. In this case, x is going to be 2. But if x is 5, or if x is greater than 5, then x is going to be bigger than 5. If it's not, it's going to be smaller. And you can incorporate all this stuff with functions and with all kinds of other data types as well, right? Oh, here's something too you might see. Okay. So if x not equal, okay. So the exclamation mark with an equal sign, that means not. If it's not equal to 0, okay. Then we'll, you know, we'll print line again. And then we'll say, number needs to be something, or let's just say input, input needs to be an int. Okay. Oh, I kind of screwed up the beginning there. But doesn't equal 0. But what if number was a 0? Then it would run, and it would be no big deal. So this is checking to say if this value right here, this number, or this x, if it's equal to 0. Just like not equal, you do have an equal, and it's going to be the double equal sign, right? You can check that too. Check that operation. Okay. So it's going to say input needs to be an int, but that's wrong because, I mean, we would have to fix this, but you get the idea. Okay? So I think I'm going to end it there tonight. I think most people is kind of getting off. But that was just like a basic introduction into some of the Rust concepts and everything like that. I will be doing more of this series where hopefully it's a little bit more streamlined. I was a tad bit rushed. Like I said, I meant to be in NixOS, and then when I went to go stream, the OBS from NixOS wouldn't connect to to stream here. So I had to reboot my machine, get in Gentoo, find everything, and do all that stuff. So I was a tiny bit more rushed than I would have liked to have been. But what I'm gonna start doing, I'm gonna try to make this just a little bit better for you guys. So you're not as bored. But definitely though, like get on the Rustling website. All right, do some chapters of the book by yourself. If you really want to learn, do some of the chapters by yourself. All right, and play around, make a lot of mistakes. Okay, and try to figure out those mistakes because, the mistakes that's what's going to teach you how to write Rust code. You could watch me or hear me talk about it, or Pyro or whoever, but if you don't practice and you don't make the mistakes yourself, and if you don't type in the code yourself, if you're just copy and pasting someone else's code, you're going to learn a little bit, but you're not going to learn as much as you would if you, just buckle down, spend an hour a night, just going over the material that you've learned. That's a big thing too, right? So, all that being said, I hope you guys have a good rest of the night. And until next time, you guys take care, be safe, and peace.